Okay, hello everyone. This is TM105 Introduction to Computer Programming, and this recording will cover all of Meeting 1. Meeting 1 is basically an introduction. It introduces the course, it introduces what programming is, and it introduces the Java programming language. Let me go to the objectives. You see, in each and every meeting you have a list of objectives. Now this objectives, it's good to read before the meeting, and then directly after you take the meeting you come back to it and you check, was I able to achieve all of these objectives? If not, it means there is something missing. You need to restudy it. Now the main objectives is to understand something called an algorithm. Write a simple Java program. It will be just an introductory program, a hello world, just to know what Java is and how to run it. Get familiar with the IDE. Explain the basic syntax of a Java program, what a Java program is, how it is divided. Create, compile, and run Java programs. So how do I start a project? And develop Java program using, now it says over here IntelliJ. Well, not necessarily IntelliJ, it's any IDE, using an IDE. I will be using the NetBeans IDE for the following recordings. Alright, now what a program is. Basically, you tell a program, a computer, what to do through a program. So you write a program so that you provide instructions, you inform the computer. The computer is basically an empty machine, a set of hardware waiting for you to give it a proper way of how this hardware should function. Now computer programs, you see, they are instructions, they are orders, steps, do the following. Computers do not understand the human language. Notice that we are not mentioning artificial intelligence applications. No, it's not like a generative AI that you can ask it to do something and it will do this thing. No. How are computers made to understand? You write a program. So everything you need to work, to interact with this machine, this piece of hardware, is you need an actual program. So programs are written using an object-oriented language. Now, good and logical programming is developed through good pre-code planning. Before you write a program, you need an algorithm. So we will see what an algorithm is. An algorithm is the logic part, an ordered set of steps for how things can be done. We will take examples. But first, algorithms can be divided into pseudocodes or flowcharts. Before I go into the details of these two, let me just go directly and show them to you and then come back. So this is one of the examples that we have. In this example, we need to calculate the average. The average is basically take the sum of the values over how many values you have. So assume you have a total of 6 values. You see, calculating the average is basically dividing the sum by 6. Alright, so let me check the pseudocode, which is an algorithm of how to find out the average of 6 numbers. You see, start, something started, use variables. Now this will be ambiguous at this time. It might not make sense because we did not study what variables are. So you can ignore this line. Input sum. So take the sum, you can write it in another way. Take the value of sum as input from the user. You see, it has to be somewhere between English and programming. So there is no actual syntax for pseudocode. You can modify this, but keep the same logic. To calculate the average, you divide the sum by the total, and it happens the total is 6. And then you provide output. You can write this as provide output. And then stop. This is where you finished. Now take a look at the flowchart. We have to know the symbols of the flowchart. But the flowchart, there's a start, then there's a special symbol for taking input or providing output. Then there's another symbol for doing some processing, such as calculating the value of average, and using the same input output symbol again and the stop symbol. So any of these two is simply explaining the logic. We are not telling the computer what to do, we are just explaining the logic. So let me go back. So an algorithm, either pseudocode using English-like phrases, easy to understand, and it is like an outline to your program, just headlines, points, bullets. A flowchart is a graphical representation using specific symbols. You see, these are the flowchart symbols. You have the terminal, which is either the start or the end, and you have the input output, we saw this, you have the processing, and you have the flow line, which tells you the direction from which symbol you are going to which other symbol, or from which element to which element, from which stage to which stage. In computers it could be from which instruction to which instruction, or from which block to which block. So we will see that this is just to indicate direction. Now the decision and the connector, these will be explained later, even though they are part of this presentation or this meeting. I will skip them, because in this meeting we will not be explaining this decision. I will come back to it at a later time. At the end of meeting 2 we take the decisions. Now a sequence is a step of instructions from one line to another. Decision is when you decide on something, and looping is when you repeat. So today we will see the sequence. In meeting 2, the first part, we will also take sequence. Then in the second part of meeting 2 we will take decision, and at the end of meeting 3 we will see the looping. So I will skip the slides for decision and looping. Alright, sequence, we've seen this. Let me take the other example. There's another example over here. Now this example will be coded in meeting 2. Design an algorithm which will accept two numbers from the user. So I need to take two numbers from the user and calculate the sum and the product, printing the answer on the screen. Now you can try to do it yourself, like you can stop over here now, you can pause, try to draw the flow chart, or let me try to do it with you, for example, and then we will see it in the slides. Here's my flowchart drawing tool. This is the Pencil software. You might take it in some other course. So let me create a new document. Pencil is just for sketching your own designs and shapes. So you can check the tools that you have. You see, these are the common shapes. You can browse over them all, and one of these over here is for the flowchart. So this is the tool for the flowchart. Now you might be using a different version than this one. This was the most recent at the time of recording the video. Alright, you see the technical term terminal. Alright, you can increase the size, maybe something, or just terminator. Alright, anyway, just this one I can drag it, drop it. You see, this is my start. I can modify the size. Now every tool has a different way, different behavior. I can simply just check what I can over here. I need to add content, so just double click and write start. You can make the font definitely larger, so just increase the font size if you want to. So this is my start. I will compress it a little bit here. Let me try alright, let me try to compress it. Here it is. Alright, this is my start. Now according to the slides, I need to take two values from the user. Now you are free to do it any way you want. You see, you are not programmers right now. You are not developers. You still do not know that you might not be able to take two values at the same time. But since you are just designing a program, so just add the input output. You see, this is the input output symbol, and okay, I'm having problem. Here it is. enlarging the size. Alright, it's okay. Double click, take two numbers as input, or let me say from the user. Now I can make it, I can add to it as input, I can do whatever I want. So here it is, take two numbers from the user, and this is font 20. Now of course I need a connector. Now you can put the connector, and then you can connect the symbols. You can drag it, put it to the middle, take the next corner. Okay, doesn't want to here. Let me just try to. Alright, here it is. Now, how will this pencil help me? You see, if I need to move this, you see the arrow, it's the connector, the sequence is just going with you. So this is a good practice, better than doing it on Paint or Word or anything else. So having a tool to design your flowchart would make it easier for you. So now I have the start. The next step is to take two numbers from the user. Now once I have the numbers, I can do a process. So over here, sum is equal to number 1 plus number 2. Now even though I wrote it this way, you could write it differently, like calculate the sum and store it in variable sum. So it's really up to you how to write it. I would just keep it like this. It is very logical. Now I need another process to calculate the product. Now even though my diagram might be different from the one in the slides, it's not wrong, because this is my approach. This is the way I am thinking of the solution. Now we'll go to the slides and we will see the difference. Product is equal to number 1 plus number 2. So let me just increase the font a little bit, and let me put my connecting lines. Let me get this over here. Alright, here it is. I need to go to the center, another one over here, and to the center, and this one goes to the center over here. I still need just two of these, so I will take my input output symbol, display the sum and product. See, this means I'm providing the output, so display the sum and the product. And let me get my terminal over here. Okay, I need to change the size. Alright, I will add the stop, and I will modify the font, and then I need my connectors, because this is a sequence. It's only one step after the other, Alright, now this is it. This is my flow chart. You see, I started with nothing, and once I know what the symbols are, what they mean, what we need from this tutorial is basically the first 4 symbols, which are the terminals, the input output, the processing, and just how to flow from one symbol to another. Alright, this is my logic. This is an algorithm. Now let me go to the slides and see how they did it. I told you it might be a little different. You see, this is the start. Now input number 1, number 2. This is the input. Sum is equal to number 1 plus number 2, and they provided the value of sum. Then product equal number 1 times number 2, they provided the product, the value of the product, and then there's a stop. Now if I code my algorithm and if I code this algorithm, what the user will see might be exactly the same, might be identical, but I have two different approaches to solving the same problem. And this is very normal. People think differently, so it's very normal to code things differently. You will take later on in another course, the data structures and algorithms, how to code in an efficient way to have a program that can perform in a good, fast, saving memory, and being like have something better than other programs. Alright, you can read the pseudocode yourself. Now I will go directly to, I will skip the decision and the repetition, and I will go directly to popular high-level languages and few details about Java, and then I will start coding my first Java program. You see, in these popular high-level languages, you do not have to memorize them, no need to memorize them. But these are some of the most common, whether they are still being used or not being used. For example, COBOL. COBOL is rarely used these days. There's a lot of better alternatives. It's a very old language, and there's a lot of better alternatives. Fortran, for example, it might not be very useful these days. But if you go to Java, for example, Java is extremely essential. Python is extremely essential. Now Pascal, for example, Pascal is a very old language and I doubt it is still in use. C# is a very powerful and common language. C++ will always be there, whether the C++ or the Visual C++. So just read them, take a brief idea what they are. Now we will be learning in this course how to use the Java programming language. It was developed by Sun Microsystems. Now Oracle bought Sun, so Sun is now part of Oracle, and it is widely used for developing platform independent, not only internet applications, different kind of applications. You can even use it to develop apps for the Android operating system. Java is available on so many different architectures, so many different platforms, and you have used a Java program at some stage already. I am sure of that. Alright, now why Java? Java is one of the most used computer programming languages. Now Python is a competitor, but why is Python a competitor? If you search online, you see at some times during the school periods, like when you start in the fall and the spring, Python is very common, but then the usage of Python declines in the summer because Python is mainly used in education. Now Java is used by students who are learning computer science, for example, or anything IT related, and it is mainly more used in some places than Python because of the nature. So Java is a compiled language, Python is interpreted, and they have different usage. So sometimes Java is the most common, sometimes Python, sometimes JavaScript. It really depends on what is going on and what the trend is now happening and what the new technology is emerging. Now Java is a general purpose, not specific, so you can use it for different usages. And Java is object oriented. Now this object oriented concept, this will be explained in a different course, not in an introductory course that is teaching the Java syntax. So this course is basically just to learn the Java syntax. Now Java, I said, is compiled and not interpreted. So let's see the difference between them. Python is interpreted, by the way. Let's see the difference. You see, an interpreted language is when you write some code such as the following. You can see this is a line of code. No need to know what this line is. The interpreter would directly understand it and give you an output. So you write a high-level language, you write something that you can understand and give the computer an instruction what to do and order, and directly see the result, see the output. In compiled languages, you write the code what you and computers need to understand, but computers cannot really process it. However, changing it to something easily processed by the computer is simple. You need a compiler, another program, to convert this code, high level language, something human readable, into binary ones and zeros. Now these ones and zeros have a special meaning where they are understood by the computer, and the computer can run them and provide output. So this is the concept of compiling. Now Java adds one level. To write the Java programs, you need a Java development kit, a JDK. Why? Because it comes with a compiler and the executor for you, and it adds something known as a Java virtual machine on your computer, so that you can write a program, compile it on one machine, take it to another machine having the Java virtual machine, and run it. Now the IDE, the Integrated Development Environment, is there to help you in coding. So IntelliJ is one of them. You can use it, or what we'll be using is probably an easier learning version, different IDE. I will be using the NetBeans IDE. So you can find downloading instructions on your LMS. We use Moodle as the LMS. Alright, Java programs. This is how normally you need to write a Java program. Now the IDE is going to help you, and I will show you both. The first approach would be to open an editor. You see, editor or IDE. So let me start one step at a time over here. Let me get an editor. Here's Notepad. Now this is dark theme, it's fine. You see editor, this is step 1, write the source code. Now no need to know what I am writing, but anyway, no need to know exactly. These will be, by time, you will become more used to them. By time, you will be skilled in them. Public class, I will call this the welcome. And here, public static void main. Now this is Java code. String args. As I said, no need to know each and every word, what it says, what its meaning is, and these are generally not very self-explanatory. System.out.println. You see, print might be self-explanatory. Out, providing output. I will explain these in more details. So this is the hello world, and let me use curly braces. You see, I wrote Java code. This is Java code. So step 1, use an editor or an IDE. So I'm now doing the editor mode and write a Java program. Now I will save this. I need to give it a name. Now I'm putting this on my desktop under the Java examples. Ignore the following. First I need to modify the type. This is not a .txt, so I will call it welcome.java. This is a Java program, and I will save it. Now here it is. This is my folder. This is where I stored it under Java examples. It's called welcome.java. This is a file that I have just created. Now let me go to my step 2. You see, once you have the source code .java, you need to send it. Now this looks like a flowchart, but this is just telling you the logic. You need to send it to a Java compiler, and it tells you the name over here, Java C. This will create the .class, which is known as Java bytecode. So let me see how to use my compiler and how will it create this .class. I will keep this folder over here. You see, it has only one file, welcome.java. Now I will open my command prompt. Now notice in the folder where welcome.java is, when I finish executing the line that I will be writing, it will give me the welcome.class. So this is c2 dots, okay, sorry, I need to use the backslash. So this is c2 dots backslash. I need to go to program files. I need the Java, I need any version of the JDK, it doesn't matter, and I need the binary folder, I need the Java C, and I need to compile using, you see this is Java C, I need to compile the file welcome.java. Now when I press enter, notice that I will have another file over here. So this is enter, and here's my directory. You see now I have two files. I have the welcome.class. So this Java C created the bytecode welcome.class. Now let me go to the PowerPoint presentation. The PDF, sorry. So I have the Java bytecode, the .class. Now I need to run it and get output. Now in my program I am not getting any input. So I need to be able to, in step 3, to run and execute. So I need something called the Java, not the Java C, Java, and it will give me an output. So now I will go back over here. I will write the same thing I was writing. So this is program files, Java, this is my JDK bin, and this is java.exe, not the Java C. I do not write welcome.class, it's just welcome, and this time it will give me an output. You see hello world. Here's my source code, here's my output. You see I told the Java to print HELLO space WORLD, and H is uppercase. You see it wrote it exactly the same way. So I was able to write a Java program. Alright, no need to learn these. I will be using an IDE. So this is just for you as general knowledge, how things are done in the order. Anyway, we need to focus on using an IDE, and I will start with the IDE and then continue with the slides. So here's my NetBeans. This is one of the versions I will be using. There's a version 8 with JTK available for you on the LMS. I will start with creating a new project. You can use the toolbar right away, but in case the toolbar was not available, you can always go to File, select a new project, and few easy steps. Make sure Java is selected and Java application, they should be selected by default. Okay, and you can directly click on next. Keep everything where it is. You can modify the project name if you like to, or you can keep it here. Let me modify it. I will call this project the welcome with uppercase W. Now the project names, we will discuss what you can write in them or how should you keep them. So you can keep the default in order not to have any issues with your files running, and just click on finish. Now I will zoom a little bit here. Let me zoom a little bit. Alright, first thing is the comments. You see everything that starts with /* is a comment, and it will keep on going until you reach the */. So you can keep this comment, you can compress it, or you can simply remove the comment if it is being a little bit annoying. Now for the first example, I just need to focus on the code, so I will remove the comments. You see this is comment. This package, do not remove it. NetBeans needs the package, so do not remove the package welcome. I will remove the author, also a comment. You see everything that is grayed out, I will remove everything that is grayed out. And this / is a single line comment, means after it you start writing Java code. You see it gave me an underlining, mean I wrote something wrong. So I will remove this comment and the Java code. I will remove this line. Now what I have is the main Java program. You see, let me open my notepad. Take a look at what I wrote. Public class welcome, I opened a curly brace, public static void main, string, square brackets, and args. Alright, by the way, this args you can modify it to any other value, it doesn't matter. Okay, so this args is just there like it means arguments. It's a short for arguments. So this is fine, just keep it. Now, what did we write? Public class. You see, in Java, everything is a class. In Java, everything is a class. You start with a class. Like your programs are classes. So public class, you give this class a name. Now the Java program exists of more than one class. So in my code, for the first few weeks, I will be having only one class. Now I might come to a place where I will create different classes, but this is basically another course's job. So in my course, mainly we will stick to only one class. Now a method. The class can have more than one method. Like this method is very special. There could be only one main method, and it is the starting point of your program. So it is public. Static means only one. Void, it returns nothing. We will come to these terms at a later time. And main is the name of the method. Now this method might take arguments. So we give it a string array called args. However, we might not really use them in our programs. So just memorize these two lines. Like this is the Java program. This is the main structure. You need to memorize these two lines. Now the first line of output, the first line of my program is to provide output. So this is system and an uppercase S. Alright? System, uppercase S. System dot. Now NetBeans is going to give you all of these. You can press escape if they are annoying at first. However, it is telling you what each one is. Like for example, here, let me put dot. Let me go to out and read what it wrote on top. You see, the standard output stream. This stream, this out, is already open and ready to accept output data, something you are giving to the user. Typically, this stream corresponds to display output or another output destination specified by the host environment or user. For simple standalone Java applications, a typical way to write a line of output is system.out.println and you give the data. So it gave you some info about it. So this is going to help me later on in my programs. But since I am learning, I just need to know the very basics. So after out, I'll put another dot. And I will select the println. I need to write a string. Here are double quotes. Welcome to Java! Exclamation. Now you see I have an error. This is because every Java program must terminate with a semicolon. Now be careful. There are several common mistakes. Someone might write this over here. You see error, it's wrong. This has to be part of the main. Someone by mistake might delete these two. You see the program will not run. So be very careful. If I write even system with a lowercase s, you see an error. My program will not run. Uppercase S. Forgetting the double quotes. Let me remove the double quotes. You see I have an error. My program will not run. So be very careful when you are writing your Java program to write it exactly in a way that the computer will understand. Now, can I add lines? Yes. You see, this is not an error. Can I put over here spaces? Yes. You see, this is not an error. Can I put this over here? Yes, it's not an error. Can I put this on a line by itself? Let me remove this. I added by mistake. You see, it's still not an error. But this is not a nicely written program. So let's go back. Control Z on everything over here. And this is a nicely written program. Alright, running the program. Here's the output at the bottom. I just need to press on this play button. Run the project or click or press F6 on the keyboard. So click, project is now running, and here it is, it finished. Let me zoom in. You see, this is the run result. It gave me welcome to Java exclamation. This is what I wrote over here. It was written exactly the same way. So everything inside the double quotes was written, and then it gave me build successful. Now println gave me a line afterward. Let me remove the ln. There's something called the print, and let me run this. You see, build successful is now over here next to the exclamation. So println, it will print whatever you give it, and then go to a new line, print followed by a new line, so that you can have a new line of code by itself. What if you have two system.out.println methods? Alright, this is it for my first project. Now let me go back to the slides. A simple Java program. We have a single line comment, starts with double slash. Now multi-line comment, slash star ends by star slash. And this is the program that we wrote, the welcome to Java. Reserved words. You saw that some words were blue in color. Public class. Now this string had a different color where I was doing it. It's fine, no problem. But you can modify the colors of the IDE, and every IDE has different coloring. But still, take a look at my NetBeans. You see package, public class, public static void. All of these are keywords. These are part of Java. No need to memorize them. You will get used to them with time. The reserved word is a large list. However, this large list, no need to memorize it. We will take like most of it. Like I can say that in TM105, we will see the boolean, the break, the case, the catch, the char, the class, the continue, the do, the double, the else, the float, the for, the if, the import, the int. You see, most of them we will see them in TM105. Now in later courses like an object-oriented programming course, you might see most of them. So no need to memorize them. You will learn them by yourself through practice. Now a class. As I mentioned, every Java program must have at least one class. And each class has a name. Now public class welcome. You see, this is not blue because this is a name that I gave, and I gave this name by creating the project. Now let me go to NetBeans. I created a project called welcome. You see, this is the name of the project, and it created a file called welcome.java, and inside this welcome.java I have public class welcome. Now a Java class must have the exact name as the file it is in. You see, welcome.java and double uppercase W, this is the name of the file. So when you read public class welcome, you know that it is part of a class called welcome.java. Alright, now the class names. A class name is a set of characters that are mainly letters from A to Z, uppercase and lowercase, digits 0 to 9, and the underscore character, and a $sign. A class name cannot start with a digit, cannot be a reserved word, cannot contain spaces. Now this same thing applies to variables, which we will see in meeting 2. Let me take examples. I will start with the invalid. You see, 1 to 3 student. True, you are allowed to use 1 to 3, but you are not allowed to start with a number. You see, this is the mistake. Now class, they are all lowercase, fine. They are all letters, fine. But this is a reserved word. You should not create variables or class names using reserved words. Public is a reserved word. Static is a reserved word. Void is a reserved word. Student space class. not allowed, not valid. There's a space. A space is a character. You're not allowed to use it. Student, the pound symbol, not allowed to use it. Question mark, you're not allowed to use a question mark. Now the valid ones, student with uppercase S or lowercase s, it doesn't matter. Student class doesn't matter. Having an underscore is valid. Having the dollar symbol are valid. You can even start with the underscore and the dollar symbol. You can have numbers, but not the first digit. So you see student 1 is valid. Now these two are valid because uppercase C is different than lowercase c. You see, class with an uppercase C is different than class with a lowercase c. The same for public. The main method. The main method in Java must be a static method, and every class must have one main method, and this is your starting point. So after the curly brace, this will be the main body of the main method. So this main method has a single statement. This statement is to provide output, and it ends with a semicolon. So a statement is to do some action. Now what we took over here is to have a string, and this is how it will look on the output. You saw that. Now different printing, you have the print and the println. The print does not add a new line. The println prints and adds a new line, and the printf, you will see it starting in meeting 2. It will come later. It is known to give you a formatted string. The statement terminator, every Java program ends with a semicolon. And the blocks. Now let me go to my NetBeans to see what the blocks are. Let me click directly after this curly brace. You see, NetBeans highlighted them both. If I click after the one on line 7, you see it highlighted the one for main. This is a block. You can compress a block, you see. You can expand the block. So a block is a group of lines all related together. This is my main method and what is inside main. Now this is my class and what is inside the class. So these are used to simply join your methods together. Alright, special symbols, curly braces to start and end a block, parentheses, we saw them, they are used with methods, we did not stress on them, and the square brackets, you saw them. You see, here are the parentheses, here's the parentheses for the println, and the square brackets, here they are, but I did not explain them, they will be explained later. Now, the double quotes, to indicate a string, they come in pair, the starting one and the ending one, and you know that a double slash, this is comment, so the next statement, you see I'm not writing Java, I'm writing English, is to provide output. So I'm just giving additional information in my program. Alright, and semicolon is the end. Now, proper indentation and spacing. You know that NetBeans helped me to provide indentation, but if I am writing on a piece of paper, I need to be able to indent properly. Every time I start a block, I keep a tab or a space, a set of spaces, like 4 or 5 spaces. So public class, you started a block, spaces. Public static void main, you started another block, additional spaces. So now you can easily say that this statement belongs to this block and this whole block belongs to the first block. You see, indentation helps me to read my programs. Alright, the block styles. Now, there are two ways. For example, C# adopts the first block style. The NetBeans adopts the second. So Visual Studio C#, the first one, NetBeans, the second one. You are free to use whichever you want. I will be using the second style, which makes it more compact, and since some statements do not end with a semicolon, you use that, oh, this is a block opener. You see, so it gave a meaning to how to end each and every line in your code. So this style 2, the end of line style, will be adopted in TM 105. Now let me go to exercises. What you do before next meeting, reread everything and solve the exercises. I will help you with the first 2 exercises, and then you can continue the rest by yourself. Print your name and student ID on the standard output in 2 lines. Of course, try to do them yourself. If you were unable to do them, then come back to the recording. If you were able to do them, this is excellent, and you have solutions for these exercises available on Moodle as well. So let me do exercise 1. I need to print my name and my ID on 2 output lines. I will go to my NetBeans. Let me start a new project. So this is File, close all projects, close this file, save, discard, doesn't matter. You can close the output or you can keep it, it doesn't matter. File, new project. Next, I will keep the name. I will not be modifying the project names anymore. Let me just zoom a little bit. I will not remove the comments. I will go directly to the main. Here it is. So my code should be placed inside the main method. Output means system.out.print. Now I need 2 lines, so I will not be using print. I will use println to write the first line and go to a new line. Write the name. So this is my name, and I need to write my ID. System.out.println. Now I will use double quotes with the ID as well, because what if my ID has zeros or starts with a 0? You see, a number that starts with a 0, the 0 would be ignored. So this is my ID, 6 zeros. You can put your own ID, it doesn't matter. And this is it. Now I have 2 output statements. Once I run my code, here it is. You see, I have 2 output statements after each other. So this is the first one, my name, go to a new line. So this is started on a new line, my ID, go to a new line. Now I do not have any output anymore, so the program terminated. This is the first example. Let me go to the second exercise. Print the below text. Now you see that I have 3 different lines. Again, I will go to my NetBeans. The first line, system.out.println I, the second line, love, and the third line, system.out.println Java. Do not forget the quotation marks, do not forget the semicolons as the line terminators. Press the play, you see I love Java. This is the output. Here it is in the exercise, print the I love Java. Of course this box is just there to indicate which text to print, okay? So we are not printing a box. Here it is, this is the output, this is the I love Java. Alright, complete all the exercises. Try to see what this \n is doing. This will be explained at a later time, and there's a program with errors. Try to do it, and this is it for this tutorial. Again, solutions for the exercises are available on Moodle. Thank you for watching this video.